Okay, so hi everyone. Today we will be studying about sound. Alright, sound is also an important chapter. It will stay with you all your life. You should know how sound travels, what is sound. Just go beyond what you hear. Alright, so we go into the science of sound, so let's get into it. Alright, propagation of sound. How does sound travel? Sound does not only travel through air, it can travel through all mediums. Okay, how does it travel? Sound is a form of energy. What you are hearing right now, it is a form of energy that travels through various mediums. All right now it's traveling through headphones or whatever you are hearing it on, or like even through the speakers, it goes through ears, it reaches your ears. That is all propagation. All right, traveling of sound, such as air, water and solids, it can travel through all media except for vacuum. Cannot propagate in vacuum. In space, all right, outer space, we cannot speak like this. All right, there is vacuum, there is no air, sound cannot travel over there. Okay, it propagates in the form of a longitudinal waves, alright, long waves, which means the particles of the medium vibrate parallel to the direction of wave propagation. So supposedly sound is traveling this way, as it travels it vibrates the particles. The key points to cover in this subtopic are: sound waves require a medium to travel. Alright, this is important. If there is no medium, it cannot travel. They cannot propagate in vacuum. The speed of sound depends on the medium through which it travels. How much the particles will vibrate. If it vibrates more, and the property of the material through which sound is going, okay, if the particles are able to vibrate more, then it will travel faster. Simple. In air it can travel really fast, okay, and in solids even faster. I'll show you. The speed of sound depends on the medium through which it travels. In general, sound travels faster in solids, slower in liquids and even slower in gases. Alright, if you have heard of that string phone that people used to make, alright, through cups, okay, there is a string attached and this cup, okay, someone is hearing over here, someone is speaking over here, okay. How does it travel? It can travel pretty easily. Sound waves travel through this solid and they travel pretty efficiently, okay. They will travel faster in solids, slower in liquids and even slower in gases, okay. Air, it travels less efficiently. If you have seen a railway track, okay, a train coming this way, okay, train coming this way, you might be even 10 kilometers, 50 kilometers away. You put your ear to the ground, okay, and you will be able to hear it traveling. Why? Through this solid, okay, this solid. The vibration can be felt long and it travels pretty fast, okay. Sound waves can be reflected, refracted and diffracted, similar to other types of waves, alright. So like light is also a wave, okay, sound is wave. As long as it is a wave, it can be reflected, bounced, it can be refracted, bended, diffracted, goes back, whatever, okay. So these are the examples of waves that shows vibration of particles, okay. Terms related to sound. Now there are some important terms related to sound. First is amplitude. Amongst those waves, how high is it going? That is the amplitude, how high the wave goes, okay. It refers to the maximum displacement of particles in a sound wave from their mean or equilibrium position. It determines the loudness of sound, okay. Higher amplitude, more loudness, okay. Time period. It is the time taken by a sound wave to complete one full cycle of vibration, okay. One full cycle of vibration. Now how much time did the particles take or the wave took? Okay, to complete one full cycle. Okay, how much time? This is time period. Frequency, it is the number of complete vibrations or cycles per unit time and is measured in hertz. How many times it went up and down, up and down, up and down, that is frequency. It is measured in hertz. Frequency is inversely proportional to the time period. If time period is increasing, alright, it will have less frequency. Okay, if time period is alright shorter, okay, tick 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 tick, this will be this is more frequency, it went to and fro more times. Okay, so it is inversely proportional. How do we show inversely proportional? Supposedly A and B are inversely proportional. Okay, inverse. How do you show this? A proportionality sign 1 upon B. Okay, A is equal to 1 upon B. Okay, this is how we show proportionality. Okay, there's an inverse relation. One is in the numerator, one will be in the denominator. Okay, so T and F are inversely related. Now we come to the characteristics of sound. Okay, sound has three primary characteristics that help us perceive and differentiate between sounds. How will you differentiate between my sound, a lion's sound, and a bird's sound? Alright, your ear knows there's a difference. How does it know that? By these characteristics. Okay, first, the loudness. Okay, it is determined by the amplitude, like I told you. Alright, greater amplitude leads to a louder sound. See this. Greater amplitude leads to a louder sound. Okay, quality. It refers to the unique characteristics of a sound that enables us to distinguish between sounds produced by different sources. Okay, we use quality of the sound. Okay, what type of sound it is, what quality of sound it is, to differentiate between who is making a sound. Okay, pitch. It is related to the frequency of the sound. Higher pitch means more frequency. Okay, and it will be like a screeching sound. Okay, something of very high frequency above our frequency range, we will not be able to hear it. Okay, so higher frequency corresponds to higher pitch, while lower frequency corresponds to a lower pitch. Okay, range of hearing. The range of frequencies that average human ear can hear is approximately 20 hertz to 20,000 hertz. Okay, 20 hertz to 20,000 hertz, 20 hertz to 20,000 hertz. This is what I am able to hear. This range. Earthquake waves. Now, earthquakes are also kind of waves. Okay, it travels through solid. Earthquakes generate various type of waves that propagate through the Earth's crust. Okay, the two main types of earthquake waves are P waves, S waves. You can see the P waves, S waves. They are longitudinal waves and are the fastest seismic waves. Alright, this is the fastest earthquake you will feel. Okay, the fastest traveling of the waves. Okay, and these are longitudinal. Longitudinal means long. Okay, so like I'll show you. P waves can travel through solids, liquids and gases. This is an example of a longitudinal wave. Okay, longitudinal wave. Okay, S waves. They are transverse waves and are slower than P waves. S waves cannot travel through liquids or gases, only through solids. So a major difference between P waves and S waves is P waves can travel through everything, but S waves can only travel through liquids and gases, not solids. Okay, so see this. Noise and music. Of course, how we distinguish sound is noise and music. Noise and music are two distinct types of sounds. Key points to cover include noise. Noise, it's a random, unpleasant, irregular sound that lacks any specific pitch or pattern or rhythm. Noise is often unwanted, can be disruptive. You will immediately identify what is noise. It is unpleasant, you don't want to hear it. Okay, someone shouting, someone making bad noises, that is just sound. It irritates you. Music. What is it is pleasant to hear. Alright. It comprises of patterns, pitches. Our brain sees it as soothing. Okay, music is created intentionally and enjoyed by listeners. Something can be music to someone and it can be noise to someone, so it depends on every other person. Okay, now we come to noise pollution. Of course, noise can be a sort of pollution. Noise pollution refers to excessive and unwanted sound. Construction, horns, alright, honking, yeah, all these things are unwanted, unpleasant sounds in the environment that can be harmful to human health and well-being. When I come to pollution, sound of unpleasant character or very loud character can be harmful for our ears. Harmful. This is noise pollution. Sources of noise pollution: industries, traffic, construction sites, loud music, household appliances are common sources of noise pollution. Effects of noise pollution: what it will have an effect on you? It can lead to hearing loss. You might become deaf. Sleep disturbances: you might not be able to sleep. So, sometimes it happens, there's a party nearby your house and they are playing loud music, alright, late night. That will disrupt your sleep. That is noise pollution to you. Stress, decreased concentration, and other health issues. It can also cause anxiety. Some people have heart problems. It can be harmful for them. Control and prevention. Noise pollution can be reduced by implementing noise barriers. What are noise barriers? They prevent sound from escaping a particular room or a particular area, using quietry machinery, enforcing regulations, promoting public awareness. Everyone should know about this. Now we come to the human ear. This is your ears, this is what you see. This is what you don't see. This is the working of the inner ear. Okay. So the human ear is an intricate organ. Intricate means it's sensitive, it is complex, okay, organ responsible for hearing and maintaining balance. Okay, explain the structure and functions of the ear. Now, outer ear, okay, this ear, it consists of pinna, this, and the ear canal. This is the ear canal, that is dark holes that you see in each other's ears. The pinna collects sound waves. It is shaped like this so that it will be able to collect sound waves. Okay, sound waves travel this way, okay, and directs them into the ear canal. Ear canal, okay, so this will go like over here, ear canal. Okay, middle ear. Now we come to this portion. Okay, it contains the eardrum. This is the eardrum. You can see this. And three small bones. Okay, these are three small bones called ossicles over here. There are also bones inside. These are very small, called hammer, anvil, and stirrup. Remember these names. These are the part of ear. They can ask you which of these is not a part of the ear or which of these is a part of the ear. You should remember the name. The eardrum vibrates in response to sound waves. Sound waves travel, this will vibrate. Okay, which are then amplified by the ossicles. These ossicles will amplify it, alright, increase it so that you can hear it. Inner ear. Now we come to the inner ear. Okay, it includes cochlea, okay, here you can see the snail like structure which converts sound vibrations into electrical signals. Okay, so over till here it was vibrations. Now this has converted it into signals so that it can travel through nerves, auditory nerves, and reach our brain, which will characterize which type of sound it is, what is the person saying, what am I hearing, okay, which converts sound vibration to electrical signals that are sent to the brain via the auditory nerve. Now balance. How does ear help us maintain balance? The inner ear also contains structure like semicircular canals, okay, that help maintain balance and equilibrium. Alright, we have ears, okay, a person has ears. This helps him maintain balance, okay. The atmospheric pressure inside them helps him maintain a balance. Now what is the range of hearing? The range of frequencies that the average human ear can hear is 20 hertz to 20,000 hertz. This is the range of hearing. It is important because anything above this or below this you won't be able to hear. Simple as that. Alright, this is tried and tested, and this is the frequencies that we as humans can hear. Anything above this will be harmful for you, anything below this will be harmful for you. Okay, you won't be able to hear it. So that will be all for today.